Module 7.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 7.1. How can we visually summarize quantitative data? Why do we need tools to summarize data? Once data has been collected, the next step is to look at the data to gain useful information. Saying something useful about raw data can be difficult, if not impossible. How can we summarize a quantitative variable? Now we will turn our attention to summarizing quantitative variables. We are going to focus on how to visually summarize a quantitative variable. When describing a quantitative variable, we consider the following three questions. What is the general shape of the data? Where are the data values centered? And how do the data vary? These are all aspects of what we call the distribution of the data. Plots can help us answer all three of the questions. To illustrate the visualization of quantitative data, we will look at a new data set. Located in the video script is a website which hosts many interesting small data sets. One of the data sets on the website has information about different types of cereal and their dietary information. A copy of the data set is provided for you on Canvas. This new data set has several different variables, each of which are measured for the different cases, where the cases are each of the different brands of cereal. Located in the video script is a full list of the different variables. Open up the data set on your computer and take a look. Notice that describing the data just by looking at the raw data would be difficult. We are going to look at some different plots that will help us describe the data set. Definition. A common way to visualize the shape of a data set is a dot plot. In a dot plot, each case is represented by a dot and the dots are stacked. It provides an easy way to see each case. Dot plots are useful when we have a small number of observations. Let's look at an example of a dot plot of the variable calories from the cereal data set. Looking at the plot, notice that the calories for each of the 77 types of cereals are represented by a dot on the plot. Recall that one of our goals is to describe the center of the data. Looking at the plot, we can quickly see that the center of the data is around 110 calories. Further, the cereal with the lowest number of calories has 50 calories per serving, and the cereal with the most has 160 per serving. The plot allows us to quickly assess this information, whereas looking at the raw data would be hard to see. Additionally, we want to be able to describe the shape of the data. This is the same as saying the shape of the distribution. We are often interested in the general big picture shape of a distribution. A distribution shown in a plot is called symmetric if the two sides approximately match when folded on a vertical center line, right skewed if the data are piled up on the left and the tail extends relatively far out to the right, left skewed if the data are piled up on the right and the left tail extends relatively far out to the left, and bell-shaped if the data are symmetric and in addition have the shape of a bell. Of course, many other shapes are also possible. When describing the shape of a data set, we are looking for the overall pattern. No plot will be perfectly symmetric. Notice that all bell-shaped plots will be symmetric, but not all symmetric plots will be bell-shaped. The modality of a distribution refers to how many peaks a distribution has. A distribution is unimodal if it has one peak, bimodal if it has two, and multimodal if it has three or more. Consider the dot plot of the calories. Notice that we could draw a bell shape over the dots. Even though the bell is not perfect, it is close. We would say this data set has a bell shape. Most of the points are in the center, with fewer far out at the ends or the tails. Notice that all bell-shaped distributions are unimodal. There are other ways to plot quantitative data. A histogram breaks the range of the values of a variable into classes and displays only the count or percent of the observations that fall into each class. A histogram of the data is provided below for the variable calories. Notice that the overall shape of the histogram is similar to the overall shape of the dot plot, since we are observing the same data set here. Again, we can see that the center of the data set is at 110 calories per serving, with the lowest value at 50 calories per serving and the largest at 160 calories per serving. What is the difference between a bar chart and a histogram? A bar chart is for categorical data, and the x-axis has no numerical scale. A histogram is for quantitative data, and the x-axis is numerical. For a categorical variable, the number of bars equal the number of categories, and the number of each category is fixed. For a quantitative variable, the number of bars in a histogram is up to you, or to software, and the appearance can differ according to the number of bars. Located in the video script is a website which gives more information on bar charts and histograms and discusses the difference. This ends the Module 7.1 notes.